Let's continue with our session. This session on cloud processes and precipitation. This is the session number 3. So the first paper, or the first presentation, is influence of local circulation on a spatial and temporal distribution of the precipitation near the Negro and Solimoe rivers confluence region by.
Okay, I will start now my presentation, and my name is Marcel, and my advisor is Maria Assunção, and co-advisor is Edmilson Dias. I will talking about the local influence of local circulation on the spatial and temporal distribution of the precipitation near the Negro and Solimoe rivers confluence region. When you're looking for Amazon region, you can see very well a lot of rivers. For example, Negro rivers, Solimoe rivers, Amazon rivers, and Tapajós rivers. And it's a zoom on my region of study, and you can see here the width of the rivers. For example, here you can see the width of the Negro River is about 10 kilometers, and you can see here too the Manaus City, and you can see the width of the Solimoe. And they show that in the afternoon night period, they show the production of the precipitation of the Amazon rivers, and in the night and the morning period, they show the increase of the precipitation of the Amazon rivers. And here we have the paper made by Fitzgerald 2008, and they show high values of the rainfall fraction over the Amazon rivers in the nocturnal time. The objective of this paper is to analyze the role of the local circulation on the spatial and temporal distribution of the precipitation close region, where the confluence and Solimoe rivers. And here we have a slide by data, and we use data from TRIM. TRIM is a tropical rainfall measurement system. Is a tropical rainfall measurement mission, and the data used was this product 3B42. It's a rainfall rate, and the data frequency is about 3 hours. It's 3 hours, and the grid space is 25 kilometers. And here we have the distribution of the grid points, spatial distribution. We use data from weather station. Specifically, we use data from airport weather station. We use data from Eduardo Gomes weather station and Ponta Pelada weather station. And this data is hourly data. And we use the dew point temperature and velocity and wind direction. And here we have the spatial localization of the weather station. We have the station localization. And in methodology, we made some wind frequency of the wind frequency, and we made plots, polar plot. The polar plot is a wind frequency in function of the wind direction information. And we used vapor pressure as any atmospheric, as any moisture indicator. And in precipitation, we made some composites of precipitation in 8 times every 3 hours in local time. And we made the gradient of accumulated precipitation, and we made this analysis for dry and wet periods. And here you can see the result. It's a polar plot. What's this? You can see if you have a plot that we have quadrants. We have 4 quadrants, and and the shaded information is wind frequency. The shaded information is wind frequency. And the contour is local time. Here you can see that it is Portuguese, but it is local time. And you can see, for example, 3 hours, 6 hours, 9 hours. And when you look for this figure, you can see that there is a seasonal variation of the wind. In the first month, you can see that the wind, the maximum values is on the first quadrant. And in the winter, you can see that the high values of wind frequency is in the second quadrant. And you can see too the signal of the breeze. You can see here that this seasonal variation it's occurred due to the action of the trade winds. It's a seasonal variation of the trade winds, the maximum value. And you can see here, for example, in August, some high values of the wind frequency that it represents the river breeze. It's occurred due to the action of the river breeze because it's in daytime. In the second figure, you have the same idea. You have the same seasonal variation of the wind, but it is data from Ponta Pelada Airport Station. And here you can see very well too the seasonal variation of the wind. And you can see, for example, in August, high values of the wind frequency in the night. And it's occur due to the action of the land breeze. Here is vapor pressure calculated for this weather station. In the first one, you can see that the vapor pressure is a function of wind direction. And when you look at this figure, you can see very well. For example, when the wind comes from Amazon City, you can see low values of the vapor pressure. You can see very well low values of vapor pressure when the wind comes from Manaus City. And when the wind comes from the river, you can see high values of the vapor pressure. And here you can see the same idea. For example, when the wind comes from Amazon City, you can see low values of vapor pressure. And when the wind comes from rivers, you can see high values of vapor pressure. And here we have the distribution, a spatial distribution of the precipitation. When I look at this figure, you need to see at morning. At the morning, you can see high value of the precipitation over the rivers. It's very easy to see. For example, 8 local time, 8 and 11 local time. You can see high value of the precipitation over the rivers. It's occurred due to the action of the land breeze. And here you can see the low values of precipitation over the rivers. And in the afternoon, it is occurred due to the action of the river breeze. And here we have the same idea, but before was for wet season, and here is for dry season. And you can see the same idea of high values of precipitation over the river in the morning, and the low values of precipitation over the river in the afternoon. Some conclusions: in both weather stations, when the winds come from south, I found high values of vapor pressure, and when the wind comes from southeast, decrease the values of the vapor pressure of the Glasgow Airport Station. And when the wind comes from north, decrease the values of vapor pressure of the Ponta Pelada Airport region. And about the distribution of the precipitation, we have some conclusions. In the afternoon period and the early night, minimum values of accumulated precipitation are observed of the rivers and the maximum values of the land. And in the dawn and the early morning, the accumulated maximum values are found of the rivers.
Thank you. Questions? Comments?
No. We are talking about the precipitation. Are you talking about precipitation? Or no, it's not wind. This arrow is gradient. Gradient of precipitation. Spatial distribution. Yes, yes. It's the ideas of migration. One of the Morales.
Morales?
Mm-hmm. Yes. Yeah, we were talking about the legs of the type. Show again. Because it was UTC, and I changed it to local time, and you need the take the UTC minus 4 hours, and I made it because that you can see it. Mm. Okay.
Okay. One more question, please.
No. I just look at for precipitation, not radar system. Yes, but I use it for